Okay, hi. Let's start this one. So the free body of this one, we've got M2G going down and tension going up. I'm drawing those arrows the same size on purpose because they're in balance. So we want to keep the blocks from moving, which means all arrows should balance. If they're unbalanced, that means we're accelerating, which means we're going to start moving. And then this guy, we've got normal. Ooh, that is not a straight line. That is unacceptable. Okay, so I'm going to draw the free body here, and then like on this side, I'm going to do like the angles and stuff. So this is normal. And then we have MG going straight down, and we have tension going this way. Okay, it says this one's 20 kilograms, this one's 25 kilograms. So that one's heavier. So there's no friction. This thing would be going that way. But since there is friction, it's holding us back and going this way. So friction must be going this way. Okay, that's not a given. Maybe it could have gone the other way. We had to logic that through. The blocks, we want to figure out the friction. Okay. Let's do this one, but like split the MG into its components. So we're going to have normal coming out this side, this tension coming out here, and be careful that you draw this tension and this tension the same length. And that has to be the same length as that. I'm going to do MG cosine theta going into the hill. And I'm going to do friction going this way, just a little bit friction. And then we've also got MG sine theta. But Miss Ryan, how do you know sine theta was going down the hill? Well, because at the bottom of the hill we have a stop sign. Huh. Oh, wow. Okay. We need to do friction. We know friction equals mu times the normal. So we need to find that normal. From our free body, we can tell that normal equals mg cosine theta. So that's m1, m1g, m1g, m1g. M1 is 20, and g in your class is 10 for some reason. And that theta is 30 degrees. Cosine 30 is not a handy number. Sine 30 is, but not cosine 30. Cosine 30, make sure you're in degrees, not radians. Times times just 20 times 10. Okay, so I got a normal force is equal to 173.205 newtons. Normal force, newtons. What is the coefficient of static friction? Coefficient of friction is a weird way to say mu, or like, I think you've been drawing a letter U. Okay, so we want to figure that out. We've got normal. Do we have this friction force? No. Okay. But we know that within our drawing, going up the ramp has to balance what's going down the ramp. So we know friction plus mg sine theta, m1g sine theta, has to equal tension. But we don't know what tension is. We also know that this tension has to equal this tension. Otherwise, your rope doesn't work. Okay, same rope, same pulley, same everything. These tensions have to match each other. So this tension equals m2g. So this also equals m2g. So we're trying to figure out what friction is, but we know friction plus mg sine theta, m1g sine theta, equals m2g. So friction equals m2g minus m1g sine theta. M2 is 25, G is 10, M1 is 20, G is still 10, sine of 30. Okay, 25 times 10 is 250, minus sine of 30 is a half, half of 10 is 5, 20 times 5 is 100. That ends up being 150 newtons. I don't trust my mental math at all, even a little bit, so I'm also going to do it like this. Sine of 30 times 20 times 10. Ooh, that's 100. Okay, and then 25 times 10 minus 100. I got it right. That doesn't always happen. Okay, so the friction force equals 150. The normal force equals this. We can plug stuff in. So friction equals 150 equals mu, and the normal is 173.205. Some people say mu, they say it like moo, like what a cow says. So there's a lot of cow puns on the internet written by physics teachers. It's a good time. 205. Okay. 0.866. And coefficient of friction does not have a unit. It's a ratio of forces, so it has no unit. That happens to be what the cosine of 30 equals, so I'm real suspicious. Let's sus. So let's double check. So we've got our normal equals m1 g cosine theta. Cosine theta. m1 is 20, g is 10. $173.2. Okay, I'm going to store that as x just so we don't lose any decimals. Friction and mg sine theta are going the same way. M2g is going the other way. M2g minus M1g. M2, 25. G is 10. M1's 10. Nope, M1's 20. G is 10. Sine 30. I know I did that math real careful. So 150 divided by second answer. 0.866. It happens to equal the cosine of 30. That's very strange. Okay. Oh, hey, answer here. Yeah, we did it. Bet. Alright.